Good morning, guys. Here we try to solve the second in delta functions. First one I already solved, attractive delta potential function. Second one, okay. And the problem is a particle of mass m is confined to the right half space, okay. In one dimensional by an infinitely potential at the origin. This is infinite potential at origin, okay, and this is confined in the right half of the space. And here is x is equal to here is the infinitely peak delta functions. There is also an attractive delta function potential at b of x is equal to minus b naught time of a of delta of x minus 8 x is equal to a. Okay, x is equal to a is an infinitely long peak, and where a is greater than 0. So find the expression for the energy of the bound state, first one, and second one, what is the minimum value of b naught required for a bound state. So solution goes, in order to construct the wave functions for the bound state, we first evaluate some properties, and it must vanish at x is equal to 0. Okay, this is here, the wave function must be vanished because this is an infinitely long potentials, and it is continuous, and its derivative over the equation similar to the last one at x is equal to a. Okay, at x is equal to a, this is a continuous, or it must obey same equation as previous one, then delta function 1. So I may be right here Schrodinger equation. I think you know, if you guys seen already, then you don't need to come here, but if you are not, then I may be say you this is studied in del square h square by 2m del 2 by del x square psi minus this one is a potential. So b naught time of a of delta, here is a plus commonly, okay, but minus because this is the delta function. This is called ke plus b is equal to energy, okay, kinetic energy plus kinetic energy operator plus potential energy operator equal to energy operator, okay. So minus b naught time a of delta of x minus a. So this is the kinetic energy operator, this is potential energy operators, or potential energy, and equal to I h cut time, this psi delta psi by delta t. Okay, so in previous equation I already told you we need to integrate equation 1. So once we integrate equation 1 and taking this on that side, so we got equations, and we do derivatives, or we check the derivatives at x is equal to plus a or minus a. Okay, once approaching this side and once approaching this side. Okay, this one is something called plus side, or I maybe says all these functions and all this one. So we got then b naught time of a of b naught a of delta of x minus a, so equal to x minus a, so this is equal to a. Okay, delta function at a, so b naught a time of psi of a. Okay, because delta function goes out, that goes to the psi of a. Guys, I tell you how to integrate or differential delta function. Okay, this just taking a value at x is equal to a, so we need to put all the value at x is equal to a. Okay, if we need to integrate these functions, okay, so with respect to delta of x, okay, so the integral goes to b naught a time of then we need to just put it psi, okay, psi of x times of all those things, so its value goes to the psi of a. Okay, once we have wave functions, then we just put to x is equal to a. Okay, here is this one also, so this integral goes to r, and this is apply everywhere in delta function. Just we need to put a value of delta functions. If it is a single in x minus a, it's not a x minus a whole square. Okay, then method is different. We just need to in this form, and delta of x minus a or a minus x is same thing. So this one equal to b naught a time of psi of x equal to minus h cut square dividing by 2m time of delta psi of x and delta x at a plus, and minus delta psi of delta x of x at a minus. So then we know away from the points, then x is equal to, we know then the x is equal to 0 and 1. It has a bound state energy. Okay, and energy is like minus h cut square alpha square dividing by 2m. You mostly find energy in same way once we are dealing with the bound state. So here we need to find alpha. Okay, because we don't know alpha. So once we need to find the alpha, then we know the function is continuous. Function is oh, we know the function, this is a delta functions. Okay, we know once then x is equal to 0, then our wave function is like a e to power minus alpha time mod x. Okay, but this is not the case. This is at x is equal to a is delta function, and here is infinitely long potential. So first thing, we need to use the constraint and then deduct from there. So we know wave function is the combination of something like e raised power minus alpha x or e raised power plus alpha x. Okay, so because this wave function is once, then at origin, so at we just shift from some amount from origin, okay, and put a delta function. So wave function is like combination of these two. So wave function is like psi of x is equal to a sine hyperbolic alpha x. So this is between x to a. Okay, this is here to here, and then our e raised power minus alpha x. So this is greater, x is greater than a. Okay, so once we says then approaching from this side. Okay, so this is a plus side. Okay, greater than a. So we need to put here this function here. Okay, and then this one is here. So putting this function here and here, and then comparing. So we need to match the two eigenvalue and their derivatives. Okay, firstly we need to match these two eigenvalues, and then we need to match our derivative, then we find value of alpha. Okay, so first one, I just take here a sine hyperbolic alpha x equal to b e raised power minus alpha x. Okay, so here we just need to put this wave function psi of x is greater than 0. So this one, so b naught time of a, and psi of x is equal to b e raised power minus alpha x, and equal to minus h cut square dividing by 2m, h cut square dividing by h cut square dividing by 2m time of delta psi by delta x, delta this one now. Okay, so alpha comes first, minus alpha time of same thing. So b e raised power minus alpha at a plus alpha a. Okay, and then minus this one is minus delta psi by delta x. So delta psi is a sine hyperbolic alpha x. So a is common, a is same, to sine hyperbolic is cos hyperbolic alpha x time of alpha. Oh, alpha a, so cos a x replaced by a time of alpha. So taking alpha minus alpha from both the side, this become a plus. So b naught a b e raised power minus alpha x is equal to minus minus plus h cut square by 2m time of alpha, and here is b e raised power minus alpha a plus cos hyperbolic alpha a. So put this equation number 2, and then we need to divide e raised power minus alpha x. So if you don't know guys, sine hyperbolic alpha x, so I tell you sine hyperbolic alpha x is like e raised to power x minus e raised power minus of x dividing by 2, and cos hyperbolic, so here is a plus only. So we need to divide from e raised power minus alpha x, e raised power minus alpha x from both the side. Okay, or alpha a guys. Okay, here alpha a, and here also need to put alpha a because at a. So alpha a, so we need to, then this one is cancelled. Okay, and here become minus minus plus, and minus minus plus, and that goes to a cot. Okay, that is equal to cot hyperbolic alpha a. So first to eliminate a in the second equation, then it says the, so firstly we need to eliminate a or b, either one of them. Okay, from first equation. Okay, eliminate from here a. Okay, taking a outside, so a equal to b e raised power minus alpha x dividing by sine hyperbolic alpha x. So sine hyperbolic alpha a. Okay, we need to put all the value at a, and here also guys put a. Yeah, here also you need to put a because I am dealing at a. Okay, So put in equation 2. Okay, put 3 in 2. Okay, so you get so once you put it simple, then you get equation, and which is, and once you put here, okay, you replace by this equation. Okay, here a is this one. Okay, is cos by sine is equal to cos by sine equal to quaternion hyperbolic, and it is for minus alpha a, and this is for minus alpha is cancel. Okay, this is upon here, it is for minus alpha, it is for minus alpha is coming common out. Okay, and cancelling by these equations, and here it is for minus alpha a is b plus cot hyperbolic alpha a. So my equation becomes b naught time of a equal to h cut square alpha dividing by 2m time of 1 plus cot hyperbolic alpha a. Okay, so this equation comes in there. So multiply both side by sine hyperbolic alpha a. Okay, this side and this side also. Okay, cot is equal to cos by sine, so cot is equal to cos by sine, so you need to multiply both the sine by sine hyperbolic alpha x. So multiply both side by sine hyperbolic alpha x. Okay, or alpha a, guys, because I am dealing with a. Okay, so here is sine hyperbolic alpha a, and here I just put 1 and dividing by this whole equations. Okay, and once I'm doing all those things, then I got equations which is equal to sine hyperbolic alpha square x square alpha by 2m b naught a time of e raised power minus alpha e raised power alpha a. Okay, guys, don't worry, this is extremely simple. So you need to open up here and dividing by these equations and multiplying by this equation from that side. So just only e raised power minus alpha is left. Okay, if you can't understand these steps, then comment me and I explain you. But you just need to put, and here I already write sine hyperbolic alpha x and cos hyperbolic alpha x, the cos hyperbolic x. Okay, and sine hyperbolic. So this is just e raised to power x plus e raised power minus x dividing by 2. Okay, so just open the cot hyperbolic or sine by cos hyperbolic, and here is the sine hyperbolic, and everything is cancelled out, and then e raised power minus e raised power alpha is left only. So and this thing equal to h cut square alpha dividing by 2m b naught a equal to 1 minus e raised power minus 2 alpha a. Okay, so we need to open up this one. Okay, this is equal to e raised power e raised power x minus e raised power minus x dividing by 2. Okay, so this 2 comes okay, 2. So the you need to do this one. Okay, so you need to, this is equal to sine hyperbolic alpha a. Okay, so sine hyperbolic alpha a or alpha x. Okay, sine hyperbolic, so here is a only. Okay, so you need to just dividing by this one. Okay, one of them is cancelled, it is called alpha a. Okay, so alpha a, here is alpha time of a, and here is alpha time of a. One of them is cancelled, 1 minus, and this one is, and then that is equal to this time, and here is 2, and then 2 by 2 cancels. Okay, so I will put 2 here. Okay, and 2 to 2 cancel. So this equation determines the value x, and which determine the bound state energy, and there is only one solution for sufficiently large value for v naught. Okay, this equation determine the value of alpha. Okay, this one you just put, and then there is the only one solution for bound state energy. Okay, and part B tells us what is the minimum value of v naught required for a bound state. So we need to find a minimum value of v naught. So B naught of minimum required for bound state. Okay, so the minimum value of B naught for creating a bound state is called a B0. Okay, so B0 I already written. It is found that assuming that the binding energy, so binding energy goes E goes to 0, which means then alpha goes to a 0. Okay, so be easily looking the equation, this one. Okay, put it for, so we need to put so we find we find the small value of alpha. Okay, so this is equal to, so alpha goes to 0. So alpha goes to 0, we need to put here alpha goes to 0, this is 1. Okay, so it comes h cut square alpha dividing by m b naught a equal to 1. No, equal to m b naught. So alpha goes to 0 for small value of alpha, and we need to find. So this is equal to minus h square alpha dividing by 2 m b naught a equal to 2 alpha a for small value of a. So this is called 2 alpha a for small value. We need to open up this term. Okay, this one is exponential terms. So if you know how to open up exponential, then it's easy. If you don't know, then I tell you guys. So this is equal to, then you find here from this first order correction we need to look, and b naught comes here equal to h cut square dividing by 2m a square. Thank you. So this is its power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial. So we just need to here put this for minus 2 alpha x is equal to 1 minus 2 alpha a plus time of square of this term dividing by 2 factorial up to so on. Just take here h cut square by alpha dividing by m. B naught a is equal to 1 minus 2 alpha a. So 1 to 1 cancel, and then just look here. So h cut square alpha by 2 m b naught is equal to 2 alpha a minus plus, or b naught is equal to h cut square by 2 m a square. This is the b naught for minimum. Okay, thank you guys.